Hi, I'm Brandon, and this is my partner Thomas, and we decided to invent something called power flowers. And so our goal is to lower your energy bill the way that nature intended. So our challenge statement, we noticed that fossil fuels are a huge part of the energy production around the world. But there's a lot of consequences with fossil fuels. They provide a negative effect on the environment as well as many other things, which we'll go over in a second. The reason they're still being used though is because they are cheap and they're easy to use. And that's why we want to make a way that is cheaper, more time efficient, and it's cleaner, and it's just efficient and more efficient in general. So facts about fossil fuels, 80% of energy created in the United States was made from fossil fuels. So in figure 1 you can see right about there, yeah, that's about 80%, yeah, that's all fossil fuels. So when fossil fuels get burned, they create or they emit greenhouse gases that get locked in the atmosphere, causing our a temperature rise here on the surface level. So that's not the only thing that fossil fuels do. Mining for fossil fuels causes land degradation, and when we use them, it pollutes our waters and our air to where it makes it inhabitable. And it also makes the oceans more acidic. So within the past couple of years, ocean acidity has risen 30%, which is crazy. So 38% of energy produced is produced by fossil fuels, and that's 38% of it went to power people's homes. So we're looking at a way to try to make a cleaner energy source that will just make this null and void, where we don't have to use fossil fuels to heat people's homes.
All right, so for our product design, our solution is to tackle this problem at the residential level and at the commercial level. So power flowers are a modular system. So there's going to be one hub that is connected to your house. And you can add as many flowers as you want, so it's less of a commitment for the individual user. And you put them in your backyard, your front yard, wherever they can collect energy. So how they work is they're all hooked up to this one hub system, and each individual flower has 2 motors that control the angle in which it is facing. There are 4 petals on each flower, and on each petal there's one photosensor. And those photosensors compare values to each other's and move the motor accordingly so that they're always facing 100% the sun in the most efficient way. There already exists something like this, but as you can see in this image here, it is quite large, quite expensive, and takes a large team to put in, while this one is less of a commitment and much smaller. You can buy it at any retail store, and it's a lot easier to use and hook up to your house. We modeled our power flower in COMSOL. So at the top, this top plate here represents the protective glass over every power flower so that they can stand the average weather throughout the United States. This bottom panel here represents the silicon of the solar panel. And these 3 lines are the copper wires that conduct both heat and electricity away from the solar panel so that it doesn't overheat. And this big bar represents the air that passes over the copper wires to cool off the system. Because a possible side effect of these solar panels always facing the sun is that they can overheat. Everyone knows that as the temperature increases, the power output of the solar panel increases with it. Until a certain point, there is a power loss with this, where they can overheat and start losing energy as they get too hot. So this is modeled at a temperature that is not efficient for solar panels. As you can see, 340 Kelvin is a little too hot. This one is at its peak operating temperature, which is about 320 Kelvin. And you can see it's operating just about the same. Here are our calculations for the extent of our project. The peach box here represents the individual partitions of the average household electricity consumption. So we have air conditioning, heating, water heating, refrigerating, lighting, entertainment, your washer and your dryer, and even like all those small appliances that you have around your house. In the grayer box right here, you have the average household monthly electricity consumption in the United States for each individual house. These three green boxes represents the three different sizes we offer for power flowers. They all differ in the size of the diameter of the flower, which will then increase the output of each flower. And then down here in this blue box is the interesting part. It represents, and it shows how many of each size power flowers you would need to cover that specific part of your bill. For example, entertainment, you would only need 7 large power flowers to cover that bill. To cover your refrigerator, you would only need 7 large power flowers to cover that bill. And here is our pie graph that we got from the U.S. Energy Information Administration. And as you can see, air conditioning, space heating, water heating, refrigerators covers a big chunk of the average energy use in the United States. And then all of these small things added up together makes up a large chunk. And even one power flower could cover this and take that out of your monthly energy bill.
So our modes of heat transfer, we had all 3 types of heat transfer. So the first one we had was radiation, and that comes from when the sun emits its rays onto the silicon panel, and this was the equation that we would use to solve for the amount of energy. And so next is conduction. So from the silicon, it transfers heat down to the copper wire through physical touch, and we assumed that it was not a one-dimensional system, so we used the gradient for the temperature to show that. And for convection is the last mode that we had, and that happens when the air passes through the little vent holes to cool down the copper wires and to make the system a little bit more efficient. And this is the equation that we use for that. So how it relates to biomimicry? It's supposed to model a sunflower, as in it's supposed to rotate and face the sun and to get the maximum exposure so that we can get the maximum energy out of it as possible. So we also want to make it look like a sunflower as well, so that it is more appealing to consumers, and if it looks nice, they're more apt to put it in their garden and more apt to purchase the item. So in conclusion, our power flowers will be way more beneficial to everyone. So they'll be more time efficient because people won't have to spend time searching and mining for coal and oil and other fossil fuels. And it's more cost efficient because it lowers your average energy bill. So it's also cleaner because, I mean, you can't get cleaner than solar energy. It's the cleanest form of energy that we've discovered so far. And it's more efficient. So 10 power flowers will literally cover your lighting bill for your house. So let's all lower our energy bill the way that nature intended.